At 2 p.m. on a Tuesday, 66 million years ago, the world ended in 24 hours. Hello there and welcome to this quiet space where time moves slowly and we can sit with the weight of what once was. Tonight we're not going to talk about theories or possibilities, we're going to walk through something that actually happened. Something so catastrophic, so absolute, that it reshaped the entire planet in a single day. This is the story of the last 24 hours of the age of dinosaurs, not as a distant abstraction, but as a timeline, minute by minute, hour by hour. From the moment the sky split open to the moment the sun rose on a world that would never be the same. Before we begin, I want you to do something. Take a moment to think about your last 24 hours. What did you do yesterday at this time? What about this morning? The meetings, the meals, the small moments that made up your day. Now imagine that all of it, every hour, every minute, is the countdown to the end of everything you know. That's what happened 66 million years ago. Somewhere a dinosaur woke up. Somewhere a creature drank from a stream. Somewhere, life continued as it always had. And none of them knew that before the day was over 75% of all species on Earth would be gone. This isn't fiction. This isn't speculation. The evidence is written in rock, in ash, in the thin layer of shocked quartz and iridium that circles the globe like a scar. Scientists have reconstructed this day with remarkable precision, piecing together what happened in those first seconds, those first minutes, those first terrible hours after an asteroid 6 miles wide struck the Yucatan Peninsula at 45,000 miles per hour. And what they've found is almost too vast to comprehend. But tonight we're going to try. We're going to slow it down, make it real, make it felt. Because this is not just the story of how the dinosaurs died, it's the story of how the world breaks and how, impossibly, life finds a way to survive. So settle in, let your breathing slow, and let's go back to a morning 66 million years ago, when the sun rose over a world that had no idea it was living its last day. The day begins like any other. The sun rises over what will one day be called the Yucatan Peninsula, but right now it's a shallow tropical sea, warm and teeming with life. The water is clear, the color of turquoise, and beneath the surface, ammonites spiral through the currents, their chambered shells catching the early light. On the distant shore, a herd of hadrosaurs, duck-billed dinosaurs, move slowly through the shallows, their heads dipping to pull up water plants. The air is humid, thick with the buzz of insects, some as large as your hand, their wings catching the morning sun like stained glass. Farther inland in what will one day be North America but is now a vast floodplain crossed by wide, lazy rivers, a Tyrannosaurus Rex wakes from sleep. She's massive, over 40 feet long, her skin tough and scarred from decades of survival. She's hungry. She's always hungry. Her territory stretches for miles and she knows every part of it, every trail, every water source, every place where prey might gather. This morning she'll hunt, not because she knows what day it is, but because that's what she does. That's what she's always done. It's 8 a.m. In the forests of what will become Montana, a small mammal no bigger than a rat emerges from its burrow. It's been hiding all night from predators, from the tyrannosaurs and the raptors that rule this world. But now, in the relative safety of morning, it searches for seeds, for insects, for anything that will keep it alive another day. It doesn't know that it's one of the lucky ones, that its size, its burrowing habits, its ability to survive on almost nothing, will be the traits that matter most by the time the sun sets tonight. It's 9 a.m. By 10 a.m. the sun is higher, and the heat is building. Across the planet, life continues in all its terrible beauty. In the shallow seas, mosasaurs hunt, their bodies cutting through the water like living torpedoes, their jaws lined with teeth that can crush bone. On land, herds of ceratopsians, horned dinosaurs with massive frills, graze on the ferns and cycads that carpet the forest floor. They're wary, always watching for predators. But today feels like any other day. The air is still, the sky is clear, there's no warning. It's 11 a.m. Somewhere in space, invisible to everything on Earth, an asteroid is approaching. It's been traveling for millions of years, a piece of rock and metal left over from the formation of the solar system, wandering through the darkness until by chance its orbit intersected with Earth's. It's enormous, 6 miles across, roughly the size of a small mountain, and it's moving at a speed that's almost incomprehensible, 45,000 miles per hour, 20 times faster than a bullet. If you could see it, if you could somehow stand in space and watch it approach, you would see it as a dark point against the stars, growing larger with every second. But no one sees it. No one knows it's coming. It's 1 p.m. At 1:30 p.m., if there were anyone capable of looking up and understanding what they were seeing, they might notice something strange. A new star in the sky, growing brighter. But there is, the dinosaurs, for all their size and power, don't look at the sky that way. They don't track objects. They don't predict. They live in the now, in the moment, responding to what's in front of them. And what's in front of them right now is just another afternoon. The hadrosaurs are still grazed. The tyrannosaur has made a kill and is feeding on a fallen ceratopsian. The mammals are hiding in their burrows, waiting for night. Everything is normal. It's 1:50 p.m. At 1:59 p.m., the asteroid enters Earth's atmosphere. It's moving so fast that the air in front of it doesn't have time to move out of the way. It compresses, heats, turns to plasma. The asteroid itself begins to glow, brighter than the sun, a second sun falling from the sky. If anything looks up now, they see a light so intense, it burns. But there's no time to react, no time to run, no time to hide. The asteroid crosses the distance from the upper atmosphere to the surface in less than 2 seconds. 2 seconds. That's all the warning the world gets. It's 1:59 p.m. and 58 seconds. At exactly 2:00 p.m., the asteroid strikes. It hits in the shallow sea, just off the coast of what will one day be Mexico. The impact is unlike anything that has ever happened in human history. Unlike anything we have words for. The asteroid is moving so fast that it doesn't slow down when it hits the water. It doesn't splash. It punches through the ocean like it isn't even there, vaporizing a column of water a mile wide and hundreds of feet deep in an instant. And then it hits the seafloor, and the earth itself breaks. The first thing that happens, in the very first microsecond of impact, is that the asteroid ceases to exist as a solid object. The force of the collision is so great that the rock and metal are instantly vaporized, turned into a superheated plasma hotter than the surface of the sun. This plasma expands outward in all directions, at thousands of miles per hour, a shockwave of pure energy that obliterates everything in its path. In the first tenth of a second, a crater begins to form. Not gradually, explosively. The seafloor is punched downward, compressed by forces that are almost beyond calculation. Rock that has been solid for hundreds of millions of years is liquefied, melted, thrown into the air as molten droplets. The crater expands, deeper and wider, a wound in the earth itself. In 1 second, it's a mile deep. In 5 seconds, it's 5 miles deep. The rock at the bottom of the crater is compressed so violently that its crystal structure changes, creating shocked quartz, a form of quartz that can only be created by the most extreme pressures. This shocked quartz will be found all over the world, in a thin layer of rock that marks this exact moment in time. In 10 seconds, the crater is 10 miles deep and 30 miles wide. The walls of the crater are not stable. They collapse inward, then rebound outward, like a drop of water hitting a pool. But on a geological scale, mountains of molten rock rise and fall. The entire Yucatan Peninsula is shaking, not like an earthquake but like the surface of a drum being struck by a giant hand. And then the shockwave reaches the surface. It travels outward from the impact site at supersonic speed, a wall of compressed air and superheated plasma that flattens everything in its path. Trees, if there were any nearby, are stripped of their bark and set on fire before they're blown over. The water that was vaporized in the first microsecond of impact is now a superheated steam cloud, expanding outward, mixing with molten rock, creating a pyroclastic flow, a ground-hugging cloud of hot gas and debris that moves at hundreds of miles per hour. But we're getting ahead of ourselves. Let's slow down. Let's see what this looks like from the perspective of someone living through it. Because right now, at 2:00 p.m. and 15 seconds, Most of the world doesn't know anything has happened. The impact site is remote, far from most of the concentrations of life, but that's about to change. At the moment of impact, there's a flash of light, not just bright, blinding. If you were standing 100 miles away and happened to be looking in that direction, you would see the horizon light up like someone had just turned on a second sun. The light is white, searing, so intense that it would damage your eyes if you looked at it direct. And then seconds later, you would feel heat, not the warmth of sunlight, but heat like opening an oven, like standing too close to a fire. The thermal pulse from the impact reaches out hundreds of miles, and everything it touches begins to burn. Animals 100 miles from the impact site don't have time to understand what's happening. One moment they're going about their day. The next, the air around them is hot enough to ignite dry vegetation. Trees burst into flame, leaves curl and blacken, and then before they can even process the heat, before they can try to run or find shelter, the shockwave hits. Imagine standing still and then being hit by a wall of wind moving faster than sound. That's what it's like. The shockwave arrives as a physical force, a wall of compressed air that picks up everything in its path and throws it. Trees are uprooted, boulders are moved, and animals, even the largest dinosaurs, are knocked off their feet, tumbled, broke. A full-grown tyrannosaur, weighing 8 tons, is lifted and thrown like a toy. It doesn't matter how strong it is. It doesn't matter how well adapted it is to its environment. Nothing is adapted to this. Within the first minute, everything within 200 miles of the impact site is dead. Not dying, dead. Incinerated by the thermal pulse, crushed by the shockwave, buried under falling debris. The landscape is unrecognizable. What was a shallow tropical sea is now a crater filled with churning, boiling rock. What was forest is now a scorched plain covered in ash. And this is just the beginning, because the shockwave is still traveling, expanding outward at thousands of miles per hour. And it won't stop until it's circled the entire planet. It's 2:01 p.m. But the shockwave is not the only thing spreading outward from the impact site. There's something that will in many ways be even more deadly. The impact has thrown an enormous amount of material into the air. Millions of tons of rock, vaporized by the initial collision, condensed into tiny droplets of molten glass. These droplets, called tektites, are ejected upward with so much force that they leave the atmosphere entirely. They arc up hundreds of miles into space, where they hang for a moment, suspended, and then they begin to fall. But they don't fall slowly. They fall at orbital velocities, streaking back into the atmosphere like meteors, thousands upon thousands of them all at once. And as they re-enter the atmosphere, they heat up. The friction of re-entry turns them into glowing embers, and collectively, all of those embers falling at the same time, create a heat pulse that affects the entire planet. It's 2:05 p.m., and the sky is beginning to glow. Let's shift perspective. Let's travel across the planet, to what will one day be called Montana, thousands of miles from the impact site. Here life is still going on as normal. The small mammal from this morning is back in its burrow, sleep. The tyrannosaur has finished its meal, and is resting in the shade of a large conifer. A herd of Triceratops is moving through the forest, their young staying close to the adults. The day is warm, quiet, and then someone looks up. The sky is changing. It's starting to glow, a faint orange light that grows brighter by the second. At first it looks like a sunset, but it's the middle of the afternoon, and the light is coming from all directions, not just the west. Animals that are sensitive to light notice it first. Birds, if we can call them that. The small feathered dinosaurs that will one day evolve into modern birds, become agitated. They call out, a high-pitched alarm that spreads through the forest. Something is wrong. The light is getting brighter, and then the air starts to get hot. The tektites, thousands upon thousands of them, are re-entering the atmosphere now, and the heat they're generating is immense. It's not like the focused heat of the thermal pulse near the impact site. It's more diffuse, spread across the entire sky, but it's still enough. The temperature at ground level begins to rise. It starts at a few degrees, noticeable but not yet dangerous, but it keeps rising. 5 degrees, 10 degrees, 15. The air itself is heating up, and there's no escape from it.
It's everywhere. It's 2 p.m. The animals start to panic. The Triceratops herd breaks into a run, the adults bellowing, the young struggling to keep up. But there's nowhere to go. The heat is in the air, inescapable. Small animals, the ones with less body mass, start to overheat first. Lizards, insects, small mammals, they can't regulate their body temperature fast enough. They collapse, gasping. The larger dinosaurs fare better. For a while, their size gives them some thermal inertia, but the temperature keeps rising. 20 degrees, 25. The air shimmers with heat, and then the forests begin to burn. Not from a single fire spreading outward, but from everywhere at once. The sky is now glowing bright orange, and the radiant heat from the re-entering tektites is intense enough to ignite dry vegetation. Pine needles curl and burst into flame. Dead wood smolders and then catches. Within minutes, fires are springing up all across the landscape, not because they're spreading from the impact site, but because the entire planet is being heated from above. It's like putting the Earth under a broiler. Everything flammable starts to burn, and once it starts, it doesn't stop. It's 2:15 p.m. The Tyrannosaur, massive and powerful, is running now. Its instinct is to flee, to find water, to find shelter, but the forest is burning around it. Smoke fills the air, thick and choking. The heat is unbearable. Other dinosaurs are running too, all in different directions, all panicking. Some of them collide, trampling each other in their desperation. A young hadrosaur trips, falls, and is immediately engulfed in flames. Its cries are high-pitched, terrible. The fire spreads to its parents, who are too panicked to help. Within seconds, they're burning too. The small mammal in its burrow is still alive. The burrow is deep, insulated from the heat by layers of soil. It can smell smoke. It can feel the temperature rise, but it stays where it is, pressed against the cool earth, waiting. This is what it's evolved to do. Hide, wait, survive. It doesn't know that this simple behavior, this instinct to burrow and hide, is what will save its lineage. That millions of years from now, its descendants will inherit the earth. Right now, it's just trying not to die. It's 2:20 p.m. Back at the impact site, the crater is still forming. The initial collapse and rebound have created a ring of mountains around the crater's edge, peaks of fractured rock thrown up by the violence of the impact. These mountains are unstable, constantly shifting and collapsing. Molten rock flows down their sides like water. The floor of the crater is a lake of magma, glowing red and orange, radiating heat that can be felt hundreds of miles away. And beneath it all, deep in the earth, something else is happening. The impact has fractured the crust. The shock wave didn't just travel outward along the surface, it traveled downward too, into the rock, compressing and fracturing it. In places where the crust was already weak, where tectonic stresses had been building, the impact is the trigger that releases them. Faults slip, rock grinds against rock, and earthquakes begin. Not small tremors, massive quakes, magnitude 10 or higher, far beyond anything in recorded human history. The ground doesn't just shake, it waves, like the surface of water, rising and falling in slow rolling motions that topple mountains and open fissures hundreds of feet deep. It's 2:25 p.m.
These earthquakes spread outward from the impact site, traveling through the Earth's crust at the speed of sound in rock, several miles per second. Within minutes, they reach the other side of the world, in what will one day be India, where massive volcanoes are already erupting in a slow, steady outpouring of lava. The shock wave triggers even more eruptions. Lava fountains shoot into the air. New fissures open. The Deccan Traps, already one of the largest volcanic provinces on Earth, intensify their output. Millions of tons of additional lava pour onto the surface, along with sulfur dioxide, carbon dioxide, and other gases that will linger in the atmosphere for years. It's 2:30 p.m., but the most immediate danger for anything living near a coast is not the earthquakes, it's what the earthquakes create. Tsunami. The impact site was in the ocean, and the initial displacement of water sent out waves that are even now traveling across the shallow seas at hundreds of miles per hour. These are not normal waves, they're walls of water, hundreds of feet high,
carrying with them the debris of everything they've already destroyed, and they're heading toward every coastline in the region. It's 2:35 p.m., and the first tsunami is about to make landfall. Imagine you're a sea creature, a mosasaur perhaps, a massive marine reptile patrolling the shallow waters near what will one day be the Gulf Coast. You're an apex predator, 40 feet long, feared by everything in your domain, and then you feel it, a change in the water pressure, a vibration that comes from deep below. You don't understand what it means, but your instincts tell you to dive, to head for deeper water, but it's too late. The tsunami arrives not as a breaking wave, not like the ones you might see at a beach. It arrives as a massive surge, a wall of water that simply lifts everything in its path and carries it forward. The water level rises 50 feet, 100 feet, 200 feet in a matter of seconds. The mosasaur is picked up and thrown, tumbling through churning, debris-filled water, rocks, trees, the bodies of other sea creatures, all mixed together in a violent, chaotic slurry. The mosasaur tries to orient itself, to find the surface, but there's no up or down anymore, just turbulence. The tsunami crashes onto the land with a force that's hard to describe. Everything in its path, for miles inland, is swept away. Forests that have stood for thousands of years are flattened in seconds. Herds of dinosaurs, caught in the open, are lifted and carried like leaves in a flood. Some of them are smashed against rocks or trees. Others are simply drowned, unable to keep their heads above the churning water. The wave travels inland for miles, carrying with it millions of tons of sediment, turning the landscape into a featureless plain of mud and debris. And then, as quickly as it came, the water begins to recede, but it doesn't recede gently. It rushes back toward the sea with almost as much force as it arrived, dragging everything with it. Animals that survived the initial surge are now pulled out to sea, battered and broken. The landscape is unrecognizable. What was once forest is now barren, scraped clean down to bedrock in places, buried under feet of sediment in others. And this is just the first wave. More are coming. The impact created multiple waves, each slightly smaller than the last, but each still capable of traveling hundreds of miles inland. It's 2:45 p.m. In the deeper oceans, away from the coasts, the tsunamis pass as relatively gentle swells. The water is deep enough that the waves don't build into the towering walls they become in shallow water. But that doesn't mean the ocean is safe. The impact has done something else, something more insidious. It's injected enormous amounts of heat and debris into the water. The initial vaporization of the ocean, the shock wave traveling through the water, the collapse of the crater walls, all of it has turned the seas near the impact site into a churning, boiling cauldron. The water temperature has spiked by tens of degrees. Marine life that depends on stable temperatures, corals, plankton, fish, they start to die. Not immediately, not from a single event, but from the sudden catastrophic shift in their environment. It's 3:00 p.m. Let's go back to the land, far from the impact site, far from the tsunami. The fires are spreading now. What started as isolated ignitions has merged into a firestorm, a self-sustaining inferno that creates its own weather. The heat from the fires creates powerful updrafts that pull in more air, feeding the flames, making them hotter and faster. The fire moves through the forest like a living thing, jumping from tree to tree, creating walls of flame hundreds of feet high. The smoke is so thick that it blots out the sun, turning day into a dark orange-tinged twilight. Animals are fleeing in every direction, but there's no consistent direction of safety. The fires are everywhere, springing up in multiple locations, as the sky continues to rain down glowing tektites. Some animals run straight into new fire. Others become disoriented by the smoke and wander in circles, until they collapse from heat exhaustion or smoke inhalation. The air itself is becoming toxic, filled with carbon monoxide, sulfur dioxide and other gases released by the burning vegetation. A herd of ceratopsians, the ones with the large frills and horns, is trying to cross a river. They've learned that water is safe, that fire can't cross it, but the river is clogged with other animals, all with the same idea. Pterosaurs, the flying reptiles, are circling overhead, screeching, looking for a place to land, but the riverbanks are too crowded. Some of them try to land anyway, and are trampled by the panicking dinosaurs below. The water itself is getting warmer. Ash is falling from the sky, thick and heavy, coating everything in a gray powder. Some animals try to drink, but the water tastes like smoke. It's 3:15 p.m. The tyrannosaur from earlier, the one that was hunting this morning, is still alive, but barely. Its body is covered in burns. The heat pulse from the re-entering debris caught it in the open, and while its size saved it from immediate death, its skin is badly damaged. It's limping now, one leg injured from a fall when the ground shook. It's heading toward water, toward a lake it knows, but the landscape is almost unrecognizable. The trails it's used for years are gone, buried under ash or burned away. It's lost, something it's never been before, and it's hurt, something it rarely experienced. For the first time in its life, the tyrannosaur is prey, not to another predator, but to the environment itself. It's 3:30 p.m. High above, in the upper atmosphere, something else is happening. The impact threw so much material into the air that it's reached the stratosphere, the layer of the atmosphere above where weather occurs. This debris, pulverized rock, vaporized ocean, ash from the fires, is spreading out in a thin layer that's beginning to encircle the globe. It's not dense enough to block the sun completely, not yet, but it's scattering light, making the sky look strange, discolored. From space, if there were anyone to see it, the Earth would look like it's wrapped in a dirty haze. This haze will stay in the atmosphere for months, maybe years, reflecting sunlight back into space, gradually cooling the planet. But that's later. Right now the immediate problem is still the heat, still the fires, still the chaos. It's 3:45 p.m. Let's check in on the survivor. Because even in the midst of this catastrophe, there are survivors. Not many, and not in the places you might expect. The large dinosaurs, the ones that have dominated the planet for millions of years, are struggling. Their size, which has always been their advantage, is now a liability. They need huge amounts of food to survive, and the fires are destroying their food sources. But the small animals, the ones that have always lived in the shadows of the giants, they're doing better. The mammals in their burrows are insulated from the heat. The water helps regulate the temperature, and the depth keeps them safe from the fires burning above. They can hear the chaos, feel the ground shaking, but they stay put. This is what they do. This is what has kept them alive for millions of years while dinosaurs ruled the surface. In the water, some creatures are finding refuge. Crocodilians, the ancestors of modern crocodiles, can hold their breath for hours. They dive to the bottom of rivers and lakes, where the water is cooler, and wait. Turtles do the same, pulling into their shells and sinking. Fish that can tolerate low oxygen levels stay deep, avoiding the surface where the water is warm and choked with ash. These are not strategies that require intelligence, they're just behaviors, instincts, but they're the right behaviors for this moment. It's forced. The fires are beginning to consume themselves, not because they're running out of fuel, but because they've created so much smoke that it's blocking the sun, cooling the ground slightly, reducing the thermal pulse from the tektites. The re-entry event, the rain of glowing debris, is starting to taper off. Most of the material that was ejected has already fallen back to Earth. The sky is no longer glowing orange. Instead, it's a dark, murky gray, lit only by the fires on the ground and the occasional flash of lightning from the storm clouds generated by the heat and ash. Thunder rolls across the landscape, deep and continuous, like the Earth itself is groaning. And in a sense it is. The earthquakes are still happening, aftershocks of the initial impact, rippling out in waves. Every few minutes, the ground shakes, sometimes gently, sometimes violently. Fissures open in the earth, releasing steam and gas from deep underground. In some places the shaking triggers landslides, sending tons of rock and soil cascading down hillsides, burying whatever lies below. It's 4:30 p.m. The temperature is starting to drop, not everywhere, and not dramatically, but enough to be noticed. The thick layer of ash and smoke in the air is blocking the sun, and without direct sunlight, the ground begins to cool. But this cooling is not a relief, It's the beginning of a different kind of problem, because the same ash that's blocking the sun will stay in the atmosphere, and as the days pass, as the fires eventually burn out, the planet will keep cooling. The impact winter is beginning, though no one alive right now knows it. It's 5 p.m. Let's shift perspective again. To the ocean, the tsunamis have passed, leaving the coasts devastated. But in the deeper water, far from land, something else is unfolding. The marine food chain is beginning to collapse. It starts with the smallest organisms, the phytoplankton, the microscopic plants that float near the surface and form the base of the entire oceanic ecosystem. These organisms need sunlight to photosynthesize, to create the energy they need to live. But the ash and debris in the atmosphere are blocking the sunlight. The water is darker than it should be, and the phytoplankton are struggling. Within hours, their populations begin to decline, and when the phytoplankton die, the zooplankton that feed on them start to and then the small fish that feed on the zooplankton, and then the larger fish that feed on the small fish. The collapse is rapid, cascading up through the food chain like dominoes falling. By the end of the day, the oceans will be in crisis, but it will take weeks, months for the full impact to become apparent. For now, the water just seems quieter, emptier. It's 5:30 p.m.
On land, the surviving animals are starting to exhibit strange behaviors. Disorientation, confusion. The trauma of the last few hours has broken the normal patterns. Predators are no longer hunting. Prey are no longer fleeing. Everyone is just trying to survive the moment. In some places, species that would normally avoid each other are huddled together, seeking any source of safety. A group of small theropods, normally fierce hunters, are sheltering in a cave alongside a family of herbivores. Neither group has the energy to care about the other. They're all exhausted, burned, injured. The cave is filling with smoke, but it's still safer than being outside. It's 6 p.m. The sun is setting now, but you wouldn't know it from looking at the sky. The smoke and ash are so thick that the sun has been invisible for hours. The day never really had an afternoon. It went from morning light to a strange orange twilight to this current darkness, all without the normal progression of the sun across the sky. The darkness is total now, broken only by the glow of fires on the horizon and the occasional lightning flash. It's a darkness that feels wrong, oppressive, like the world itself is mourning. It's 7 p.m. The temperature is dropping faster now. The gas in the atmosphere is doing its work, reflecting heat back into space. What was a scorching inferno just hours ago is now cooling rapidly. In some places, the temperature has dropped by 30 degrees in the last hour. Animals that were overheating are now beginning to shiver. The cold-blooded dinosaurs, the ones that rely on external heat sources to regulate their body temperature, are particularly vulnerable. They're sluggish, unable to move quickly. Some of them, already weakened by burns and injuries, simply stop moving. They lie down and don't get up. It's 8 p.m. The night is long, longer than any night should be, because the smoke is so thick that even when the sun does rise tomorrow, it won't penetrate the darkness. For now, the world is cold, dark, and silent, except for the distant rumble of fires and earthquakes. Animals that are still alive huddle together for warmth. Some of them die during the night from their injuries, from the cold, from starvation. By morning, fewer than half of the animals that were alive at dawn will still be breathing. It's midnight. In the deepest parts of the ocean, in the burrows underground, in the caves and the crevices, life persists. Not thriving, just persisting. The creatures here are the ones with the simplest needs. The ones that can go without food for days or weeks. The ones that can tolerate cold, darkness, low oxygen. They don't know that they're the future. They don't know that they're the ones who will inherit the world once the dust settles. They're just waiting, surviving, 1 hour at a time. It's 3 southern. The fires are still burning in some places, but they're smaller now, starved of oxygen by the thick ash, running out of fuel. The landscape they've left behind is a wasteland. Charred stumps, fields of ash,
The bones of animals that couldn't escape. In the darkness, scavengers are beginning to emerge. Not the large scavengers, the ones that would normally feast on a kill. They're mostly dead, but the small ones, the insects, the bacteria, the decomposer, they move through the ash, feeding on the dead, breaking them down, returning their nutrients to the soil. This is the beginning of the next phase. The cleanup, the recycling, the slow transformation of death into the possibility of new life. It's 5 a.m. And then finally dawn approaches. Not a real dawn. The sun is rising somewhere beyond the ash cloud. But its light is filtered, diffused barely enough to distinguish day from night. The world is gray. Everything is covered in a thick layer of ash, like snow but heavier. The temperature is cold, colder than it should be for this latitude. Animals that survived the night are moving slowly, if they're moving at all. Many of them are dead, frozen in place, their bodies already being covered by falling ash. It's 6 a.m., 24 hours since we started. The day of the impact is over, but the age of consequences is just beginning. Let's pause here. Let's take a breath, because we've just walked through the worst 24 hours in the history of complex life on Earth. In one day, from dawn to dawn, the world ended. Not completely, not for everything, but for the dinosaurs, for the great marine reptiles, for thousands of species that had flourished for millions of years. This was the end. And now, as the sun rises on the second day, weak and pale through the ash, we need to understand what happens next, because the impact was just the first blow. What follows is in some ways even more devastating. The immediate aftermath is a world in shock. The fires are still smoldering. The ash is still falling. The air is still toxic. But the worst of the violence is over. The shock waves have passed. The tsunamis have receded. The tektites have all fallen. What remains is silence. A deep, oppressive silence, broken only by the occasional rumble of an aftershock, or the crack of a tree finally giving up and falling. It's a silence that will last for months, maybe years, because the animals that used to fill the air with their calls, most of them are gone. Let's look at who's left. Let's walk through the devastated landscape and see what survived. We'll start with the obvious loser. The large dinosaurs, the ones that defined the Mesozoic era, are nearly extinct. Not all of them died in the first 24 hours. Some survived the impact, the fires, the heat, but they're not gonna make it much longer, because their world is gone. The forests they depended on for food have been incinerated. The herds of herbivores they hunted are dead, and the ones that are still alive are injured, starving, too weak to hunt or defend themselves. A tyrannosaur that somehow made it through the night is wandering through the ash, its movements slow and uncoordinated. It's been 3 days since it last ate, and there's nothing to eat. The bodies of dead animals are everywhere, but they're burned, covered in toxic ash, inedible. The tyrannosaur tries to tear into one anyway, desperate, but the meat is foul, and it makes the creature sick. It vomits, weakening itself further. It will be dead within a week, and it's not alone. Across the planet, the last tyrannosaurs, the last triceratops, the last hadrosaurs, are dying slowly, from starvation, from injuries, from the cold. The age of dinosaurs is over. It's just taking them a little while to realize it. But it's not just the large dinosaurs that are struggling. Many of the smaller dinosaurs, the ones you might think would have a better chance, are also dying, because they're still reptiles. They're still cold-blooded, and the world has gotten very, very cold. The sun is barely visible through the ash. The normal cycle of day and night, of warmth and coolness, has been disrupted. It's cold all the time now. A deep, penetrating cold that these creatures can't cope with. They're sluggish, unable to hunt, unable to move. One by one they succumb to hypothermia. It's a quiet death, a slow shutting down of their metabolism, until they simply stop. But remember those small mammals, the rat-sized creatures that spent the first day of the apocalypse hiding in their burrows. They're still alive, and not just alive. They're doing relatively well, because they're warm-blooded. They can generate their own heat, maintain their body temperature even when the world around them is cold, and they're used to scarcity. They've spent millions of years living in the shadows, eating whatever they could find, surviving on scrap. Now with the dinosaurs dying, with the world in chaos, these are exactly the skills that matter. They emerge from their burrows cautiously, testing the air, sniffing for danger. The air is acrid, filled with smoke and ash, but they're used to bad conditions. They scavenge through the wreckage, finding seeds that somehow survive the fires, insects that are slowly crawling out of their own hiding places, roots and tubers buried beneath the ash. It's not much, but it's enough. They eat, they return to their burrows, they wait, and slowly, day by day, they begin to spread, because the predators are gone. The dinosaurs that would have eaten them, the raptors and the small theropods, are dead, or dying. For the first time in millions of years, the mammals can move freely, without fear. This is their moment. They don't know it yet, but this is the moment when the world becomes theirs. Let's look at the birds, or rather the proto-birds, the small feathered dinosaurs that are the ancestors of modern birds. They're in a strange position. On one hand, they're dinosaurs, part of the same family that's dying. On the other hand, they have advantages that their larger relatives don't. They can fly, which allowed them to escape some of the immediate dangers of the fires and the tsunami. They're small, which means they don't need as much food, and many of them are omnivores, able to eat seeds, insects, carrion, whatever they can find. These advantages are enough. Not all of them survive, but enough to. And from these survivors, over the next millions of years, all modern birds will descend. In the oceans, the situation is even more complex. The large marine reptiles, the mosasaurs, the plesiosaurs, they're gone. The tsunamis killed some of them outright. The rest are starving. The collapse of the plankton has cascaded up the food chain, and there's nothing for them to eat. Within weeks, the last of them will die. But smaller creatures, fish, sharks, rays, they're more resilient. Many of them die, but the survivors are the ones that can tolerate a wide range of conditions, that can eat almost anything, that don't need much food. These generalists, as they're called, make it through, and from them the oceans will slowly repopulate. The same pattern repeats everywhere. The specialists, the creatures perfectly adapted to the world as it was, die. The generalists, the ones that can survive in a wide range of conditions, make it through. It's not a fair system. It's not based on who was the strongest or the smartest or the most advanced. It's based on who happened to have the right combination of traits at the right time. Evolution doesn't care about fairness. It cares about what works. And right now, what works is being small, being warm-blooded, being able to eat almost anything, and being able to hide. But let's not get too far ahead. We're still in the immediate aftermath. The first weeks after the impact. The world is dark. The sun is blocked by the ash cloud, and what little light filters through is weak, diffuse. Plants, the ones that survived the fires, are struggling. They need sunlight to photosynthesize, to create the energy they need to grow. But there's not enough light. Some plants, the ones with seeds that can lie dormant for long periods, will survive. They'll wait in the soil, protected until the light returns. But the plants that need constant sunlight, the ferns, the flowering plants, many of them die. And when the plants die, the herbivores that depend on them die too. This is the impact winter. It's not a single, it's a process, a slow cooling and darkening of the world that lasts for months, maybe years. The ash in the atmosphere reflects sunlight back into space, preventing it from reaching the surface. The temperature drops. Snow begins to fall in places that have never seen snow before. Ice forms on lakes and rivers that have been warm for millions of years. It's a world turned upside down, where the rules no longer apply, where creatures that have thrived for eons suddenly find themselves unable to cope.
And then there's the acid rain. The impact vaporized enormous amounts of rock, including sulfur-bearing minerals. This sulfur reacted with water vapor in the atmosphere to create sulfuric acid, which falls as rain. The rain is not as immediately deadly as the fires or the tsunamis, but it's insidious. It acidifies the soil, killing plants that were already struggling. It poisons the water, making it undrinkable for many animals. It eats away at the shells of marine creatures, dissolving the calcium carbonate that protects them. The effects are slow but cumulative, adding to the already overwhelming list of challenges facing the survivors. Let's visit a specific place, a river valley in what will one day be Montana. Before the impact, this was a lush green landscape, filled with forests, rivers, and herds of dinosaurs. Now it's unrecognizable. The trees are gone, either burned or blown down by the shockwave. The river is clogged with debris, ash, and the bodies of dead animals. The ground is covered in a thick layer of gray ash that muffles all sound. It looks like a black and white photograph. A world drained of color. A small mammal, one of the survivors, is picking its way through the ash. It's looking for food, for anything edible. It finds a patch of roots that were protected by a fallen log. The roots are dirty, covered in ash, but they're still good. The mammal digs them up, eats quickly, and moves on. It knows instinctively that staying in one place is dangerous. There's no cover here anymore, no trees to hide in, so it keeps moving, heading toward a rock outcrop that might offer shelter. As it moves, it passes the body of a Triceratops. The dinosaur is lying on its side, partially buried in ash. It's been dead for days. Insects are already at work on the body, breaking it down. The mammal sniffs at the corpse but doesn't try to eat. The meat is rotten, toxic. Instead, it keeps moving. The mammal will survive because it's careful, because it's adaptable, because it's willing to eat whatever it can find and move on before danger finds it. But not everyone is so lucky. In a nearby cave, a group of small theropods, the ones that sought shelter during the fires, are still there, but they're not alive. They died during the first week, from starvation, from the cold, from inhaling too much smoke. Their bodies are huddled together, as if they were trying to keep each other warm. It didn't work. The cave protected them from the fires, but it couldn't protect them from the aftermath. This will be their grave, and millions of years from now, paleontologists will find their fossils and wonder what happened. And we'll be able to tell them, we know what happened. We've walked through it, hour by hour. As the weeks pass, the ash begins to settle. It's still in the atmosphere, still blocking the sun, but it's not falling as heavily as it was. The ground is covered in a layer several inches thick in some places, feet thick in others. This ash will become part of the geological record, a thin layer of sediment that marks the boundary between the Cretaceous and Paleogene periods. Future scientists will call it the KPG boundary, and they'll find it all over the world, proof that the impact affected every corner of the planet. The world is quieter than it's ever been. There are no large dinosaurs left, no tyrannosaurs roaring, no hadrosaurs calling to their herds, no pterosaurs screeching overhead. The sounds that remain are subtle. The rustle of wind through dead trees, the trickle of water over rocks, the occasional chirp of an insect or the squeak of a mammal. It's a world in mourning, a world waiting to see what comes next. And what comes next is slow. It takes decades for the ash to fully clear from the atmosphere. It takes centuries for the forests to regrow. It takes thousands of years for the ecosystems to stabilize. But eventually they do. Life, as it always does, finds a way. The survivors spread out, filling the niches left empty by the dinosaurs. The mammals, once small and insignificant, begin to diversify, to grow larger, to experiment with new forms. The birds spread across the continents, adapting to every environment from deserts to rainforests. The world is different now, fundamentally changed by the events of that single day 66 million years ago. But it's also still here, still alive, still evolving. But we're getting ahead of ourselves again. Let's come back to the immediate aftermath, to the months following the impact. Let's talk about what didn't survive. Because understanding what was lost is just as important as understanding what remained. The dinosaurs, as a group, are the most obvious loss. For 65 million years they were the dominant land animal. They evolved into an astonishing diversity of forms, from the massive sauropods that could weigh as much as 10 elephants, to the tiny Compsognathus, no bigger than a chicken. They occupied every ecological niche,
From apex predator to herbivore to scavenger. They were so successful, so well adapted, that it seemed like nothing could stop them. And then in the span of a single day they were gone. Not immediately, not all at once, but the process was set in motion, and there was no stopping it. The marine reptiles are gone too. The mosasaurs, the plesiosaurs, the ichthyosaurs, all of them extinct. These creatures ruled the oceans for millions of years, adapting to life in the water, with the same success that dinosaurs adapted to life on land. But the collapse of the marine food chain was too much for them. Without plankton, there were no small fish. Without small fish there were no large fish. And without large fish there was nothing for the marine reptiles to eat. They starved. The oceans, once teeming with these magnificent creatures, are empty now, silent. The pterosaurs, the flying reptiles, are gone as well. These creatures were not dinosaurs, though they lived alongside them. They were a separate branch of the reptile family tree, one that had taken to the skies. Some of them were as small as sparrows. Others, like Quetzalcoatlus, had wingspans of over 30 feet, making them the largest flying animals that ever lived. But they couldn't survive the impact winter, the collapse of the insect populations, which many of them depended on for food, was fatal. The last pterosaurs died within months of the impact. And it's not just the famous animals that were lost. Thousands of less well-known species that will never be named, never be studied, died as well. Small lizards, amphibians, insects, each one a unique product of millions of years of evolution, each one adapted to its environment in ways we can't fully appreciate. All gone. The diversity of life on Earth, which had been building for hundreds of millions of years, was cut down in a single day. It's a loss that's almost incomprehensible. But let's not end on loss. Let's end on survival. Because for all the death, for all the destruction, life persisted. And the creatures that survived, the small, the adaptable, the resilient, they would go on to inherit the earth. The mammals, freed from the shadow of the dinosaurs, would diversify and spread, eventually giving rise to everything from mice to elephants to whales to humans. The birds, descendants of the dinosaurs, would take to the skies and fill them with song again. The plants would regrow, the forests would return, and the world, scarred but unbroken, would continue. The impact was not the end. It was a transition, a violent, catastrophic transition, but a transition nonetheless. What came after was different from what came before, but it was still life, still evolution, still the endless, beautiful, terrible process of change that has defined this planet since the first cells appeared in the oceans, billions of years ago. And in that sense, the story of the impact is not just about death. It's about resilience, about the capacity of life to endure, to adapt, to survive even the worst that the universe can throw at it. And maybe, in our own small way, we're part of that story too, because we're here, 66 million years later, descendants of those small mammals that hid in their burrows while the world burned. We're here because they survived, and we're here to tell their story, to remember what happened, to bear witness to the day the world ended, and the world began again. That's not nothing. That's something worth holding on to as we drift towards sleep, as we let go of the images of fire and ash, and darkness, and allow ourselves to rest in the knowledge that life, somehow, always finds a way. Let's sit with that for a moment. The idea that we are here, right now, because of what happened on that day 66 million years ago. It's easy to think of the extinction as a distant event, something that happened in the deep past to creatures we've never seen. But it's not distant. It's intimate. It's personal. Because if that asteroid had been just a little smaller, or had struck at a different angle, or had missed the Earth entirely, the dinosaurs might still be here, and we wouldn't. The mammals might have remained small, nocturnal creatures, hiding in burrows, never evolving into anything more. There would be no primates, no humans, no one to look up at the stars and ask where we came from. The extinction wasn't just about what was lost, it was about what became possible. This is the strange duality of catastrophe. It destroys, but it also creates. It closes doors, but it opens others. The impact that killed the dinosaurs was a tragedy, a violent end to millions of years of evolution. But it was also an opportunity, a clearing away of the old to make space for the new. And what emerged in the aftermath was a world we would recognize, a world of mammals and birds, of forests and grasslands, of change and adaptation. The world we live in today is the world the impact created. Every tree, every animal, every breath of air, all of it shaped by what happened on that single day. But let's not romanticize it. Let's not pretend that the end of the dinosaurs was somehow necessary or good. It was random. It was the result of a piece of rock happening to be in the wrong place at the wrong time. There was no purpose to it, no grand design. It just happened. And that's perhaps the most unsettling part. Because if it happened once, it could happen. The universe is full of asteroids, comets, and other objects wandering through space. Most of them will never come near Earth. But some will, and when they do, we'll face the same choice the dinosaurs faced. Adapt or die.
But we have an advantage the dinosaurs didn't. We can see it coming. We have telescopes. We have computers. We have the ability to track objects in space and predict their trajectories. And if we see an asteroid heading our way, we might be able to do something about it. We might be able to deflect it, to change its course, to prevent the impact from happening. The dinosaurs couldn't do that. They couldn't even conceive of doing that. But we can. And in that sense, we're not just the inheritors of the world the impact created. We're the guardians of it. We have the responsibility, the burden of making sure it doesn't happen again. Now, let's shift our focus. Let's zoom out from the specific events of that day and think about what they mean. What does it mean that life is fragile? That an entire era can end in 24 hours? That the dominant creatures of an age can be wiped out by an event they never saw coming? It's a humbling thought, because no matter how successful we are, no matter how advanced our technology or our civilization, we're still subject to the same forces that ended the dinosaur. We're still vulnerable. We're still, in the grand scheme of things, temporary. But maybe that's not a depressing thought. Maybe it's a liberating one. Because if everything is temporary, then nothing is permanent. The mistakes we make, the problems we face, the challenges that seem insurmountable, they're all temporary too. They'll pass. They'll be replaced by new challenges, new opportunities, new possibilities. The dinosaurs are gone, but life is still here. The world ended, but the world is still here. And that continuity, that thread that runs from the past through the present, into the future, that's what matters. Not whether we last forever, but whether we contribute something to that thread, whether we add something to the story that will be told long after we're gone. Let's think about the survivors again. Not the species, but the individuals. That small mammal we've been following, the one that spent the day of the impact hiding in its burrow. It didn't survive because it was brave or strong or special. It survived because it was small, because it could burrow, because it happened to be in the right place at the right time. And from that one individual, and others like it, came all the mammals that followed. All the diversity, all the complexity, all the beauty of mammalian life. It can be traced back to creatures that were, by the standards of their time, insignificant. And that's another lesson, isn't it? That the insignificant can become significant. That the overlooked can become essential. That the small can inherit the earth. Because evolution doesn't favor the strong or the fast or the smart, at least not in the way we usually think of those traits. Evolution favors what works in the moment. And in the moment of the impact, what worked was being small, adaptable, and able to hide. The tyrannosaurs, for all their power, couldn't hide. The hadrosaurs, for all their numbers, couldn't adapt fast enough. But the mammals could, and they did. So when we think about survival, we shouldn't think about it in terms of strength or dominance. We should think about it in terms of flexibility, resilience, the ability to change, because the world is always changing, slowly, usually, but sometimes catastrophic. And when those catastrophic changes happen, the ones who survive are not the ones who were best adapted to the old world, but the ones who can adapt to the new one. That's the real lesson of the extinction. Not that the dinosaurs were weak or that they deserved to die, but that adaptability is the ultimate evolutionary advantage.
And in a universe that's always changing, always throwing new challenges at us, adaptability is what we need most. Now as we drift closer to sleep, let's bring this back to something more personal. Let's think about what it would have been like to be there to witness that day, not as a scientist studying it from a distance, but as a creature living through it. What would it have felt like to watch the sky light up, to feel the heat of the re-entering debris, to run from the fires, to hide from the shockwave, to huddle in the cold darkness and wonder if the sun would ever return? We can't really know. We can imagine, we can extrapolate, but we can't truly understand what it was like because we're not those creatures. We don't have their instincts, their perceptions, their understanding of the world. But maybe we don't need to. Maybe it's enough to know that they felt fear, that they felt pain, that they struggled to survive, because those are universal experience. Every living thing, from the smallest insect to the largest whale, knows fear, knows pain, knows the struggle to survive, and in that sense we're connected to them, across the vast distance of time, by the shared experience of being alive in a dangerous world. And maybe that's the real meaning of the extinction, not that it was a cosmic tragedy, or a necessary step in evolution, but that it was a moment when life was tested, pushed to its limits, and forced to prove whether it could endure. And it did, not because of any grand plan or destiny, but because life at its core is stubborn. It doesn't give up. It adapts. It changes. It survives. And in surviving, it carries forward the memory of what came before, encoded not in words or symbols, but in genes, in behaviors, in the very structure of the living world. The mammals that survived the impact carried with them the genetic legacy of their ancestors, the ones who lived through the age of dinosaurs, who learned to hide, to burrow, to survive on the margins. And when the dinosaurs were gone, that legacy became an advantage. The skills that were once necessary, just to avoid being eaten, became the foundation for a new way of life. The world changed, but the genes remembered. And from those memories, written in DNA, came everything that followed. And we're part of that lineage. Every human being alive today carries within them the genetic legacy of those survivors. We're not just descendants of the mammals that survived the impact. We are them, in a very real sense. The same genes that allowed them to burrow, to hide, to adapt, are still in us, still shaping who we are. We like to think of ourselves as separate from nature, as above it, as having transcended the crude mechanisms of evolution, but we haven't. We're still products of the same forces, still shaped by the same history. And when we look back at the extinction, we're not just looking at a distant event, we're looking at our own origin story. So as you lie here, as you feel the weight of your body, the rhythm of your breath, the slow drift toward sleep, remember that you are the product of survivors. Your ancestors, not just your human ancestors but your mammalian ancestors, your vertebrate ancestors, all the way back to the first cells. They survived, they adapted, they changed, they faced challenges we can barely imagine, and they made it through. You're the continuation of a story that's billions of years old, a story of survival and adaptation, and the stubborn refusal of life to give up. And maybe in your own small way you're adding to that story, not by doing anything grand or heroic, just by being here, by continuing the thread, because that's all evolution asks of us. Not perfection, not dominance, just continuation, just the willingness to keep going, to adapt to whatever the world throws at us, to survive long enough to pass something on to the next generation. And in doing that, in simply being alive, you're fulfilling the same role as that small mammal hiding in its burrow 66 million years ago. You're surviving, and that's enough. Now let's take one last look at that, not at the violence or the death, but at the moment just before dawn on the second day. The sky is still dark, the ash is still falling, the fires are still burning, but somewhere in a burrow deep underground, a small mammal is waking up. It's been asleep for hours, conserving energy, waiting for the chaos to pass, and now slowly, carefully, it begins to move. It pushes aside the soil that's partially collapsed the entrance to its burrow, and pokes its nose into the open air. The air is cold, acrid, filled with smoke, and the mammal, after hours of being underground, needs to breathe fresh air, needs to move, needs to find food. It emerges from the burrow, blinking in the dim light, its body tense, ready to run at the first sign of danger. But there's no danger. The predators are gone. The world is empty, silent. The mammal sniffs the air, testing it, and then begins to move, slowly at first, then with more confidence. It's alive. The world has ended, but it's alive. And as it moves through the ash-covered landscape, something else is happening. High above, invisible through the thick cloud of debris, the sun is rising. The light is weak, barely enough to see by, but it's there, and over time, over days and weeks and months, that light will grow stronger. The ash will settle, the skies will clear, and the sun will shine on a world that's been transformed. A world that's starting over. A world full of possibilities that didn't exist before. This is where we end. Not with death, but with dawn. Not with the end of the dinosaurs, but with the beginning of what came next. Because that's the real story, isn't it? Not the extinction, but what survived it. Not the loss, but what was gained. The world ended on that day 66 million years ago. But it also began again. And from that beginning came everything we know, everything we are, everything we might become. So rest now. Let the images fade. Let the sounds of that ancient world grow quiet. Let yourself sink into sleep. Into that other kind of darkness. The safe kind. The kind that comes at the end of every day and promises a new beginning when you wake. The dinosaurs are gone. But their story is not over. It lives on in the fossils we study, in the rocks we examine, in the questions we ask, and it lives on in us, in the genes we carry, in the world we've inherited, in the future we're building. Sleep now, knowing that you're part of something larger than yourself, part of a story that spans millions of years, part of a lineage of survivors, part of a world that's always ending and always beginning, always dying and always being born anew. The asteroid struck 66 million years ago. The world ended. And here you are, alive, awake, aware, the product of that ending and all the beginnings that followed. And tomorrow, when you wake, the sun will be there. Not the pale ash-dimmed sun of the impact winter, but the bright warm sun of a world that survived. And you'll be there too. Another day, another chance, another chapter in the long, strange, beautiful story of life on Earth. Good night. Sleep well, and dream. If you dream of ancient worlds and the creatures that walked them, dream of fire, and ash, and darkness, but dream also of dawn, of survival, of the small mammal emerging from its burrow to find a world changed but still waiting, still full of possibility. Dream of the thread that connects us all, across time, across species, across the vast distance from that day to this one, and know that you are part of that thread. You always have been, you always will be. The world ended, the world began, and the story continues. Good night. But before we let sleep take us completely, before we surrender to the darkness and the quiet, let's go back one more time, not to the impact itself, but to the hours and days that followed, because there are stories we haven't told yet. Individual stories, specific moments, the kind of details that make history feel real rather than abstract. Let's walk through those moments now, slowly, carefully, giving each one the weight it deserves. Let's start with the sea turtles. These creatures have been around for a long time, even before the impact. Their ancestors evolved during the Triassic period, over 200 million years ago, and they've weathered every extinction event since then. On the day of the impact, thousands of sea turtles were swimming in the shallow waters of the Western Interior Seaway, a massive body of water that split North America in half. When the asteroid struck, the shockwave traveled through the water, creating pressure waves that killed many fish instantly. But the turtles, with their hard shells and ability to dive deep, had a better chance. One particular turtle, a large female who had been alive for over 50 years, felt the shockwave as a sudden, violent compression. It pushed her down deep into the water, and she instinctively pulled into her shell, waiting for the danger to pass. When she finally surfaced, hours later, the world above was unrecognizable. The sky was dark, the air was hot, and the water was churning with debris, with ash, with the bodies of dead fish and marine reptiles. But she was alive, and she had an advantage. Sea turtles can go months without eating. They can survive on very little. Even in the months that followed, as the oceans struggled and the food chain collapsed, she simply floated, conserved energy, and waited. Many turtles died during the impact winter, but enough survived, scattered across the world's oceans, to ensure the species would continue.
Now let's think about the crocodilians. Like the turtles, crocodiles, and their relatives are survivors par excellence. They've been around for over 200 million years, and they've survived every major extinction event the Earth has thrown at them. On the day of the impact, a large crocodile was resting in a river delta in what would one day be Wyoming. When the ground began to shake, it didn't panic. It simply sank to the bottom of the river, where the water was cooler and the shaking was less violent. It could hold its breath for hours if needed, and it did. When the fires started, when the sky began to rain burning debris, the crocodile stayed underwater. The surface was chaos, but the depths were relatively calm. Fish were fleeing, disoriented, and the crocodile ate well during those first few hours. It didn't know that it was witnessing the end of an era. It just knew that there was food, and it was hungry. In the days that followed, as the temperature dropped and the world went dark, the crocodile's metabolism slowed. It didn't need to eat as often. It could survive on one meal a week, or even one meal a month. And when food was scarce, it simply waited, patient, still, a perfect predator adapted for a world that can be hostile for long stretches of time. This is why crocodilians survived the extinction, not because they were lucky, but because they were already adapted to survive in harsh conditions. They could go without food, they could tolerate temperature changes, they could breathe air but live in water. They were generalists in the best possible way, and those traits which had served them well for millions of years served them even better during the extinction. Now let's talk about the small theropods. The ones that didn't make it. There was a species, about the size of a chicken, with feathers and sharp claws, that lived in the forests of Montana. They were social creatures, living in small groups, hunting insects and small mammals. On the morning of the impact, a family group of these theropods was foraging near a stream. The parents were teaching the juveniles how to catch dragonflies, snapping at the air, their feathers bright in the morning sun. When the sky lit up, they looked up, curious but not alarmed. They had no concept of danger from above. Danger, for them, came from the ground, from larger predators. But the heat pulse arrived within seconds, and suddenly the air was too hot to breathe. The adults tried to shield the juveniles, huddling together, but it didn't help. The thermal radiation was too intense. Within minutes, all of them were dead, their feathers singed, their bodies collapsed in a heap near the stream. They would be fossilized in that position, a family frozen in their last moment, and paleontologists would find them millions of years later, and marvel at how well preserved they were, how you could still see the detail of their feathers, the positioning of their bodies, but they couldn't know what those last minutes were like. Only we know because we've walked through it. Let's shift to the plants. Because the plants, in many ways, were the real victims of the impact. When animals can move, can adapt their behavior, can find new sources of food. But plants are rooted in place. They can't run from fire. They can't hide from the cold. All they can do is wait and hope that their adaptations are enough. And for many plants they weren't. The ferns, which had been abundant in the understory of forests, died back almost completely. They need constant moisture and moderate temperatures, and the impact winter provided neither. The flowering plants, which had only recently evolved and were still competing with more ancient plant groups, struggled as well. Many species went extinct, but the ones that had evolved seeds capable of lying dormant, waiting in the soil for better conditions, those plants survived. Their seeds stayed buried under the ash, protected, waiting. And when the light finally returned, when the temperatures stabilized, they sprouted, and within a few decades they had reclaimed large swaths of the landscape. This is an important. The recovery from the extinction was not immediate. It took time, decades for the worst of the ash to clear, centuries for the forests to regrow. Thousands of years for the ecosystems to stabilize. And during that time, the world looked nothing like it had before. It was a landscape of ash and dead trees, punctuated by small hardy plants struggling to gain a foothold. It was a world in transition, caught between what it was and what it would become. But let's not forget the insects. We haven't talked much about them, but they were crucial. Insects are incredibly resilient. They reproduce quickly, they have short lifespans,
and they can adapt to new conditions in just a few generations. When the fires burned and the forests died, many insects died but others, the ones that lived in the soil, the ones that could burrow or hide in crevices, they survived. And they emerged into a world with less competition, fewer predators, and new opportunities. The ants, for example, which were already a successful group before the impact, exploded in diversity after it. With the large herbivores gone, with the leaf litter accumulating without being disturbed, the ants found new niches to explore. They became farmers, cultivating fungus in underground chambers. They became herders, tending to aphids and protecting them from predators. They became scavengers, breaking down the bodies of dead animals and returning their nutrients to the soil. The ants, and insects like them, were essential to the recovery. They broke down the dead, recycled the nutrients, pollinated the new plants, and created the conditions necessary for the forests to return. Now let's think about the freshwater ecosystem. Rivers, lakes, swamps. These environments were hit hard by the impact, but they also offered refuge. When the fires burned, when the air was toxic, animals could submerge themselves in water, and as long as the water didn't get too hot, as long as there was enough oxygen, they could survive. Frogs and salamanders, which need water to reproduce, were particularly vulnerable. Many species went extinct, but the ones that lived in deep lakes or fast-moving streams, where the water stayed cool and well oxygenated, they made it through. There's a particular lake in what is now North Dakota that became a refuge during the extinction. It was deep, fed by underground springs, and surrounded by rocky outcrops that protected it from the worst of the fires. Animals gathered there in the days after the mammals, reptiles, amphibians, all seeking water and shelter. The lake became a kind of oasis, a pocket of relative safety in a world gone mad. And from that one lake, from the survivors that sheltered there, new populations spread out once conditions improved. It was one of many such places, scattered across the continents, where life held on and waited for the world to heal. Let's talk about the birds again, but more specifically. Not all birds survived, but the ones that did had certain traits in common. They were small, they could eat seed, and they could fly, which allowed them to cover large distances in search of food and suitable habitat. There was a particular species, a small sparrow-like bird, that lived in the forests of what would become the southeastern United States. On the day of the impact, a flock of these birds was feeding on the seeds of a conifer tree. When the heat pulse arrived, many of them died, their feathers catching fire as they tried to flee. But a few, the ones that happened to be sheltering in the shade, survived. In the days that followed, these survivors flew south, away from the worst of the fires, searching for food. They found a valley where the fires hadn't reached, where there were still trees and seeds and water. And they stayed there, reproducing, slowly building up their population. This valley became a reservoir of avian diversity, a place from which birds would eventually spread back into the devastated areas once they recovered. And from these survivors, dozens of new species would eventually evolve, adapting to the new world, filling the niches left empty by the extinction of the pterosaurs, and many of the non-avian dinosaurs. Now let's get more specific about the mammal. We've talked about them in general terms, but let's focus on a particular lineage, the ancestors of the primates. The group that would eventually give rise to monkeys, apes, and humans, were small, tree-dwelling creatures before the They looked something like modern tree shrews, with long tails, sharp claws, and large eyes adapted for seeing in dim light. They ate insects, fruit, and small reptiles, and they were well suited to survive the extinction. On the day of the impact, one of these early primates was sleeping in a hollow tree. The tree was old, thick-barked, and partially rotted, which created natural insulation. When the fires started, the tree caught fire on the outside, but the hollow interior stayed relatively cool. The primate woke to the smell of smoke, panicked, but stayed inside, knowing instinctively that outside was more dangerous. It was a gamble, but it paid off. The fire burned past, consuming the outer layers of the tree but leaving the interior intact. The primate emerged hours later singed and frightened, but alive. In the months that followed, this individual and others like it foraged in the burned landscape, eating whatever they could find: insects, seeds, fungi, even carrion when they could get. Their flexibility, their willingness to eat almost anything, was key to their survival. And as the forests slowly regrew, these early primates were among the first to recolonize them, spreading their genes, their behaviors, their potential for future evolution. 66 million years later, their descendants would walk upright, build cities, and look back at this moment with a mixture of horror and gratitude. Let's also talk about the deep ocean. The surface waters were devastated by the extinction. The collapse of the phytoplankton populations meant that the entire food web unraveled. But the deep ocean, the abyssal plains thousands of meters below the surface, were relatively unaffected. Life in the deep ocean doesn't depend on sunlight. It depends on the slow rain of organic material from above, the marine snow of dead organisms and fecal matter that drifts down from the surface. When the surface ecosystems collapsed, this marine snow decreased, but it didn't stop. And the creatures that lived in the deep, the ones that were already adapted to scarcity, to darkness, to the crushing pressure, they survived. There are worms, crustaceans, and strange fish in the deep ocean that have lineages stretching back hundreds of millions of years. They lived through the extinction without even noticing it. Their world, so far removed from the surface, so isolated from the events unfolding above, continued as it always had, slow, dark, patient. And when the surface eventually recovered, when the plankton returned and the marine snow resumed its descent, these deep-sea creatures were still there unchanged. They're still there today, in fact, living in the same darkness, the same pressure, the same slow rhythm that has defined their existence since long before the dinosaurs and will continue long after we're gone. Now let's think about the polar region. The Arctic and Antarctic, or what would become those regions, were different during the late Cretaceous. There was no permanent ice. Instead, there were forests, temperate forests, that grew in the long summer days and endured the long winter nights. When the impact occurred, these polar forests were hit hard by the initial heat pulse, but they also had an advantage. They were far from the impact site. The shockwave and the tsunamis were weaker by the time they reached these latitudes, and the forests, adapted to survive long periods of darkness during the polar winter, were better equipped to handle the impact winter than forests at lower latitudes. Some of the plants and animals in these polar forests survived. Not all of them, but enough. And in the years that followed, as the world slowly warmed again, these survivors became the seed population for the recolonization of the higher latitudes. It's a reminder that geography matters. Where you are when disaster strikes can make all the difference. The creatures near the impact site had almost no chance. The creatures thousands of miles away had a better chance. And the creatures in remote marginal environments, places that were already harsh and demanding, they had the best chance of all because they were already adapted to survive in difficult conditions.
Let's also consider the role of chance, of luck. Because for all the talk of adaptation and fitness and survival of the fittest, there's a huge element of randomness in evolution. A dinosaur that happened to be in a valley when the shockwave passed over might have survived when others in the open were killed. A mammal that happened to be in a burrow when the fires started survived when others above ground did not. A bird that flew south instead of north might have found food when others starved. These individual decisions, these random chances, they add up. They shape who survives and who doesn't. And the survivors, no matter how well adapted they were, owe at least part of their survival to luck. This is an uncomfortable truth. We like to think that survival is about merit, about being the best, the strongest, the smartest. But it's not. It's about being in the right place at the right time with the right traits. And sometimes it's just about being lucky. The mammals that survived the extinction weren't necessarily the best mammals. They were just the ones that happened to survive. And from those survivors, selected not by merit, but by chance, came all the diversity of mammalian life we see today. It's a humbling thought, but also a hopeful one, because it means that even the least likely, the most improbable, can become the ancestors of something great. Now, as we near the true end of this journey, let's think about what it all means. We've walked through 24 hours of catastrophe. We've seen the world end. We've watched the dinosaurs die. We've followed the survivors as they struggled to adapt to a new reality. But what's the takeaway?
What do we learn from this? Maybe we learn that change is inevitable. The world that existed before the impact seemed permanent, stable. The dinosaurs had ruled for 65 million years. It seemed like they would rule forever. But they didn't. In a single day their reign ended. And the world that replaced theirs, our world, seems permanent too. But it's not. It's just another chapter, another temporary arrangement, that will someday be replaced by something else. And recognizing that, accepting it, frees us from the illusion of permanence and allows us to focus on what we can do in the time we have. Maybe we learn that resilience is more important than strength. The tyrannosaurs were the most powerful land predators that ever lived. But when the world changed, their power meant nothing. The mammals, weak and small, survived because they were flexible, adaptable, resilient. And resilience, the ability to bend without breaking, to adapt to new conditions, to survive when everything around you is changing. That's a trait worth cultivating, not just in species, but in ourselves, in our societies, in the way we approach the challenges we face. Maybe we learn that life is more than just individual survival. It's about continuation. The individual dinosaurs that died on that day 66 million years ago, they didn't know they were part of a larger story. They didn't know that their deaths would make possible the rise of mammals, and eventually humans. They just knew fear and pain and the struggle to survive. But in hindsight, we can see the pattern. We can see how their end was also a beginning. And maybe that's the ultimate lesson, that death and life are not opposites. They're part of the same process. One feeds into the other. The death of the dinosaurs made possible the life that followed. And someday our deaths will make possible whatever comes next. And maybe finally we learn that wonder is the appropriate response to all of this. Not despair, not fear, but wonder. Because the fact that we can know any of this, that we can look back 66 million years and reconstruct what happened, that we can hold in our minds the image of a world so different from our own and understand it. That's remarkable. We're animals, descended from the survivors of the extinction, and we're using the brains we inherited from them to understand the event that made our existence possible. There's something circular about that, something beautiful. We're the universe looking back at itself, trying to understand its own history. And in doing that, in asking these questions, in seeking these answers, we're fulfilling a role that no other species can fill. We're the witnesses, the storytellers, the ones who remember. So as you drift toward sleep now, as you let go of these images and ideas, carry with you this sense of wonder. You're part of something vast. You're connected to a history that stretches back billions of years. You're the product of survivors, of creatures that faced the worst the universe could throw at them, and made it through. And you're here now in this moment, able to think about it, to feel it, to understand it. That's not nothing. That's everything. The asteroid struck. The world ended. The dinosaurs died. And from the ashes, life emerged again. Different but still life, still evolving, still reaching toward the future. And you lying here in the darkness, breathing slowly, feeling the pull of sleep, you're part of that emergence. You're part of the story. And the story, as long as there's someone to tell it, never really ends. Good night. But wait, there's one more story to tell before we close our eyes. One more perspective to explore. Because we've talked about species, about populations, about the broad strokes of extinction and survival, but we haven't really talked about place, about specific locations on Earth where the drama of that day unfolded in unique ways. So let's take a journey now, not through time but through space. Let's visit the places where the extinction left its deepest marks, and see what they can teach us. Let's start at the impact site itself. The Chicxulub crater, as it would later be named, is located on the Yucatan Peninsula in Mexico. Today it's partially buried under limestone, partially underwater in the Gulf of Mexico. You can't see it from the surface, but it's there, a scar 110 miles across, hidden beneath younger rock. If you could strip away those layers, if you could see the crater as it was immediately after the impact, you would see something that looks more like the surface of the moon than anything on Earth. A massive basin surrounded by a ring of mountains, the floor covered in cooling magma, the walls still collapsing and sliding. It would take tens of thousands of years for the crater to stabilize, to fill with sediment, to be reclaimed by the ocean. But in those first days it was hell. The temperature at the center of the crater was hot enough to melt rock. The air was toxic, filled with vaporized minerals and gases released from deep in the Earth's crust. Nothing could live there. Nothing did live. It was a dead zone. A place where the planet itself had been wounded so deeply that it would take millions of years to heal. And even today, 66 million years later, the crater is still there, still visible to those who know how to look for it. It's a reminder that some impacts are so profound, they leave permanent marks, even on something as large and resilient as a planet. Now let's travel north, to what is now the Hell Creek Formation in Montana, one of the richest sources of dinosaur fossils from the end of the Cretaceous period. This was a lush, river-crossed floodplain, home to Tyrannosaurs, Triceratops, Hadrosaurs, and countless smaller creatures. On the day of the impact, Hell Creek was about 2,000 miles from the impact site, far enough that the initial shockwave was weakened by the time it arrived, but not far enough to escape. The heat pulse arrived first, a wave of thermal radiation that set the forests on fire. Then the shockwave, a wall of wind and debris that flattened trees and tossed animals like leaves. The animals here had minutes, maybe hours, longer than those closer to the impact. But it wasn't enough. Most of them died in the fires that followed, or in the cold darkness of the impact winter. The fossils we find at Hell Creek today, the bones buried in the rock, they tell the story of that final moment. There's a thin layer of sediment, the KPG boundary, that separates the age of dinosaurs from the age of mammals. Below that line, dinosaur fossils are abundant. Above it they disappear. It's one of the most dramatic transitions in the entire geological record, and it happened right here, in this landscape 66 million years ago. Let's move across the ocean now, to what is now Europe. At the end of the Cretaceous, Europe was a very different place. Much of it was underwater, covered by a shallow sea called the Tethys. But there were islands, archipelagos, scattered across this sea, each one a miniature world with its own unique ecosystem. One of these islands, located near what is now Spain, was home to a population of small duck-billed dinosaurs. They were island dwarfs, smaller than their mainland relatives, adapted to the limited resources of island life. When the impact occurred, this island was far from the impact site, thousands of miles away, but the tsunamis traveled across the Tethys Sea, and when they reached the island, they were still massive. The waves washed over the island completely, drowning everything on it. The dinosaurs, the plants, the insects, all of them were swept away in a matter of minutes. And when the waters receded, the island was barren, scoured clean. Some islands in the Tethys Sea survived the extinction, their populations hanging on in isolated pockets. But this one did. It was wiped clean, and it would be thousands of years before life returned to its shores. Now let's go to the southern hemisphere, to what is now Antarctica. In the late Cretaceous, Antarctica was not the frozen wasteland it is today. It was forested, temperate, a refuge for creatures adapted to the long polar night. When the impact occurred, it was summer in Antarctica. The sun was up 24 hours a day, the forests were green, and life was abundant. The initial shockwave and heat pulse were weakened by the distance, but the fires still came, and in the months that followed, as the impact winter set in, Antarctica got colder. But here's the interesting thing, Antarctica was already cold, at least in winter. The creatures that lived there were already adapted to survive months of darkness and freezing temperatures. So when the impact winter came, when the rest of the world was plunged into cold and darkness, Antarctica's inhabitants were better prepared than most. They had insulated burrows, they had thick fur or feathers, they knew how to survive on very little. And while many species still went extinct, the survival rate in Antarctica was higher than in most other places. It's a reminder that the harshest environments can sometimes be the safest, because the creatures that live there are already adapted to survive the worst.